Hello, welcome to video 2B for the Further Maths Conference Calculus session, where we're going to look at the solutions to the two additional questions on using the graphs of circular and hyperbolic functions for integration. So the first of those should have been the one integral of 1 over square root of x squared plus 9 dx based on using the graph of y squared minus x squared equals a squared. So the first thing to do is to write down the explicit Cartesian form of this, which should match the denominator. So I'm going to have y is equal to the square root of x squared plus a squared. I can also think of the parametric form, which is going to be x equals a sine u and y equals a cos u. Now, if I use these for my integral, this is going to suggest that because this is y, I can use an integral, a substitution. X is a sine u, and here a is going to be 3. So I've got x equals 3 sine u. That would give me dx by du is 3 cos u. Subbing all that into the integral, I get the integral of 1 over all of this thing here is y, so it's 3 cos u, multiplied by dx is 3 cos u du. That and that cancel, leaving me with the integral of 1 du, which is equal to u plus c, or r sine x over 3 plus c, which again should correspond with what you get for the standard technique for integrating functions of the form 1 over the square root of x squared plus a squared. Okay, let's have a look at the circular function one, which has got a bit of a sting in the tail. So I can use the same technique again. I can say that the explicit Cartesian form of this is going to be y is equal to the square root of a squared minus x squared, which does correspond with the denominator here. I can also use the standard parametric form for this of x equals a cos u, y is equal to a sine u. That suggests a substitution. The denominator here looks like y, so if I use a substitution of this for x, all of this can be replaced with the expression for y. So I've got x is equal to 5 cos u. Therefore, dx by du is negative 5 sine u. So my integral becomes the integral of 1 over, I can replace all of this with my expression for y, which is 5 sine u. Dx is negative 5 sine u du. So I want to multiply that by negative 5 sine u du. This becomes the integral of negative u du, which is negative u plus c, or negative of u, divide x by 5, take the inverse cos, negative arc cos x over 5 plus c. Now at this point, all of this has worked, but it seems a bit surprising. We've basically got this result when what we're expecting here is that we should have the positive arc sine. That's the standard way of integrating these things. So here's the chance to think, why have we got a slightly different result? If you want, you could pause the video now and have a play around with it and see if you can work this out. Right, so there are a couple of ways you can show that this is actually equivalent to that. The first of them is you might be aware that we can relate arc sine and arc cos to each other. Inverse sine or inverse cos, that's actually just fairly basic trigonometry work. If I've got a right angle triangle, this angle and that angle are the inverse sine and the inverse cos. Got a hypotenuse of 1, and then this is x. These angles are the arc sine and arc cos, and they add up to 90 degrees or pi over 2. All of that written in this language looks like arc sine x plus arc cos x equals pi over 2. Well, I can put all of that together in here, and I can just replace negative arc cos with arc sine plus pi over 2, minus pi over 2. Arc sine x minus pi over 2 is equal to negative arc cos x. So I can replace all of this with arc sine x over 5 minus pi over 2 plus c. Let's just call these c's c1, and I could put the whole of this constant together into a new constant, c2. An alternative and possibly simpler way of doing this is thinking back to this parametric form. This parametric form is fairly arbitrary. I could also write the parametric form of a circle as x equals a sine u, y equals a cos u, and it would still work. It would still give me the equation of the circle, and if I did all of that, then I will be substituting in x is a sine u. I differentiate and get cos, positive cos, and I wouldn't have this annoying negative sign here, and I would get the arc sine.